Dear students, today we have to discuss about your chapter 4 moving charges and magnetism. The study of properties of moving charge and magnetism was first discovered by a Danish scientist. Danish, D-A-N-I-S-H. Danish means हॉलैंडवासी, जो हॉलैंड भाष करती. A Danish scientist whose name was Weierstrass, who first discovered the moving charges and magnetism in the year 1820. So, what do you mean by moving charges and magnetism? For example, this is a conductor and let I is the amount of current flowing through the conductor. When a compass needle, this is the structure of a compass needle having two poles, north pole and south pole. When a compass needle is parallel to the conductor, and if the conductor carries some current I, then the compass needle becomes deflected like this. इमिति प्रकार नॉर्थ साउथ डायरेक्शन से डिफ्लेक्ट हो मीन्स आर सूचक कंटाटा इमती रोटेशन हो ऑटोमेटिकली. सो ये जो कंडक्टर पाखरे जो आम गोटे कंपास निडल रखिले कंडक्टर जदि किसी अमाउंट ऑफ करंट जाए तेबे ई कंपास निडल रो नॉर्थ साउथ डायरेक्शन रा कोन होए डिफ्लेक्ट हो जाए. सो द डिफ्लेक्शन ऑफ कंपास निडल इज डन बाय द अमाउंट ऑफ करंट फ्लोइंग थ्रू द कंडक्टर. अमाउंट ऑफ करंट फ्लोइंग थ्रू द कंडक्टर मीन्स द चार्जेस आर इन मोशन. The charges are in motion means it is called as moving charge, and that moving charge is directly affected upon the magnet, and hence the topic is our moving charges and magnetism. Before going to this chapter, first of all we have to clear what do you mean by magnetic field. Just like the definition of electric field, the space around a magnet, the space around a magnet within which its influence can be experienced. Its influence can be experienced is called as magnetic field. Is called as magnetic field. For example, this is a magnet and that magnet attract a piece of iron at a distance of 10 centimeter. When we just remove the iron piece at a distance of 10.1 centimeter, the iron is not attracted by the magnet. So, by taking radius 10 centimeter, if we draw a circle, the around field, the entire field around the magnet is known as magnetic field. So what is the definition? The space around a magnet. Magnet रो चतुर्पार्श्व जो स्पेस टा अछि इ स्पेस रो जेतिकी दूरता पर्यंत मैग्नेट इफेक्ट पकई थाए, this entire field is called as magnetic field. And in plus 2 level we have to read the magnet means it is a bar magnet. Bar magnet just like shows a rectangular shape having two poles, north pole and south pole. North pole and south pole. And in case of a bar magnet, always the lines of force is created from north pole and reach at the south pole. These are the magnetic lines of force. These are the magnetic lines of force. So in case of a bar magnet, the lines of force are created from north and reach at the south, outside the magnet. But inside the magnet, the lines of force are goes from south towards the north, this direction. Outside the magnet, north to south को तुम्हारे lines of force आगा जाए, and inside the magnet, south to north pole आड़ो को magnet lines of force आगा जाए. So in this case, all the lines of forces are in cyclic in nature, from north to south outside the magnet, south to north inside the magnet. That's why we can say that the magnetic lines of force are closed surface or closed path, but electric lines of force are not closed. These are called as open lines of force. The magnetic field lines, if the magnetic field lines are parallel and equidistant from each other, then it is called as uniform magnetic field. And if the lines of forces are not parallel and not equidistant from each other, these are called as uniform magnetic field. So always the uniform magnetic fields are either convergent or divergent lines of force. जदि लाइन्स ऑफ फोर्स गुड़िक पार्लाल आउ प्रति लाइन्स ऑफ फोर्स भितर गैपटा इक्वल थाए, that is called as a uniform magnetic field. And if the lines of forces are not parallel and not equidistant, then it is called as a non-uniform magnetic field. And this non-uniform magnetic field may be converge or diverge. In this case, if we draw a tangent at any point upon the lines of force, that tangent gives the direction of the lines of force. Thus, two lines of force never intersect to each other, and if they do, at that point there are two tangents, but it is quite impossible. Hence, two magnetic field lines never intersect to each other. And this is very important question for 2 mark. Why two magnetic lines of force never intersect to each other? Answer is that two magnetic lines of force never intersect to each other, and if they do, two tangents may be drawn at the point of intersection and giving two direction of magnetic field at one point, but it is impossible. If the magnetic lines of forces are very close to each other, then the magnetic field is strong, and if the magnetic field lines are further distance apart, the magnetic field is weak. In this case, the magnetic field is denoted by B. B is very strong when all are very close to each other, and magnetic field B is weak if the lines of forces are far distance apart. Since the magnetic north and south poles cannot be isolated, आपको हमें आइसोलेट करि परिया नाही कोन पई आइसोलेट मीन्स अलग करिया आइसोलेट करि परिया नाही कोन पई फॉर एग्जांपल दिस इज ए मैग्नेट हैविंग north pole and south pole. If this magnet is cut into 3 pieces, then each piece behaves as a bar magnet. जदि ई बार मैग्नेट टाको आम 3 गड़ी 4 गड़ी 10 गड़ी करिया प्रत्येक पीस गुड़िक कौन भाया काम करती बार मैग्नेट भाया काम करती thus magnetic north pole and south poles cannot be isolated and thus the magnetic lines are always closed curves because they started from north pole reach at south pole outside the bar magnet and inside the bar magnet they goes from south pole to north pole. The magnetic field is denoted by B and this magnetic field is a vector quantity. If the magnetic field is uniform, the compass needle stays in the same direction at each point. जदि मैग्नेटिक फील्ड यूनिफॉर्म अवस्था रे थाए ई भितर जदि हम गोटे कंपास निडल रखिया दैट कंपास निडल stays in same direction at each point और प्रत्येक बिंदु रे समान दिग से देखिबो कोन पई the strength of the field is constant at each and every point but inside a non-uniform magnetic field if we put a compass needle its direction will be changes from point to point because the strength of the magnetic field is not constant at each and every point. ये देख लाइन्स ऑफ फोर्स आको क्लोज होइक अछि तुम मैग्नेटिक फील्ड स्ट्रांग हबो इडी लाइन्स ऑफ फोर्स गुडी को फार डिस्टेंस रे अछि वीक हबो तेनु इ स्ट्रांग रो वीक आडू गलाडू हम प्रति पॉइंट रे कोन हबो कमी जाउची तेनु इ कंपास नील रो डायरेक्शन ना मध्ये कोन हबो चेंजेस हे पड़ेबो एंड द मैग्नेटिक फील्ड स्ट्रेंथ एट एनी पॉइंट इन ए मैग्नेटिक फील्ड may be defined as it is a vector quantity whose magnitude is equal to the number of magnetic field lines passing per unit small area. ये भीतर गोटे पॉइंट नियो ये पॉइंट को नहीं कि गोटे स्मॉलर एरिया गोटे चूज करो स्मॉलर एरिया सह always the magnetic lines of forces are normal to the point and whose direction is along the tangent drawn at that point on the magnetic field lines and this magnetic field strength B is also called as magnetic flux density. This is all about the introduction of moving charges and magnetism, and next class we have to read the Weierstrass experiment upon moving charges and magnetism. Very important topic, moving charges and magnetism. Listen, be carefully the video and understand. Thank you.